Okay. Yes, I'm Dierk Ohlerich. I'm Chaos. I'm in the scene now for 13 years. I started at Sanity with Amiga. Now I'm farbrausch. And I made several intros and demos, which are listed there. And the most interesting thing about these productions is that they're all done with a tool. And that's why I'm talking today about the tool, which is the key, or the tools we created, which are the key component to all these productions. It's not one tool, there are many tools. It's just that we made a tool, saw what went wrong, and made another one, saw what went wrong, and finally got to a state where they're quite usable. So there's actually a history to tell about the farbrausch tools. But this history starts a lot earlier. It starts when I and a few other people like Mr. Pat and Fiverr started their games company and were at the task of creating their first commercial game on their own without the help of anybody else, which was a futuristic racing game called Killer Loop. And we were thinking, what is the most important aspect of making a game fun? And we came to the conclusion that it's not the 3D engine, the special effects. We were demo sceners. We had no problem with doing special effects, we thought. We thought the things that we have to learn to do is, this is a racing game. We must get the controls right. We must get the tracks right. We must get the physics right. And we assumed that there will be a lot of tweaking if you're doing a racing game, that every curve of the track is perfect. And we made a tool to reach that goal, to make a racing game where every curve is perfect. This is a screenshot of our tool we used back then. And there's one special thing about this tool. That you see, we have a few windows where you can edit the track, but there's also one window where you can play the game while you edit it. So that actually when you were creating when the level designer chose to change the track a little bit, he didn't have to export it, go through some kind of tool chain, test it, maybe on another computer. He could immediately drive back a few hundred meters with his car, go to the and then test that curve again if it's good. Actually, the physics engine was running all the time, so when he was changing the track so that there's a little hill, he could see how the car goes down the hill because of the gravity. And I think this attempt worked. We were able to create stunning tracks, and that goal was reached totally. And that's the most important term, I think, here is turnaround times. The time you need to test something. And if you want good results, you have to reduce the turnaround times. It's the same, programmers know if they have to wait 5 minutes for a compile, they are very unlikely to compile often and test good. But if they are able to compile immediately, then everything runs a little bit better. And it's even more important for level designers and graphicians who shouldn't be so much thinking and more trying and testing. And because small turnaround times prevent frustration, they increase quality much more than you would expect from the pure time saved. It's just a totally different kind of working if you have small turnaround times. And the goal always has to be immediate turnaround times, so that you see how it changes when you change it. We also made another tool which we used to simplify textures to make them smaller, because the whole game had to fit into a PlayStation 1. And actually you see a list of textures here, and you could change how strong it is simplified, the bit depth of the texture, and you had a list of textures. You could toggle the screen to a 3D screen, so that you immediately, when you change the size of the texture, saw how the texture will look on the 3D scene. Is it too small, or, well, will it work? We actually wrote a PlayStation-like engine on PC who had all the errors of the PlayStation to make it even more realistic when we were trying out these textures. And I think we also managed to put a huge amount of textures in that game, because none of these textures was too large. And we could reach this only because the changing of the size of the texture was done with immediate feedback. Before I can go ahead to FR08, our first intro we made with the tool, I have to go to something which was a big inspiration for doing FR08. That was Kasparov by Elitegroup, which is also a tool-based demo. The modeling, and actually the tool that was done for Kasparov is something like Demopaya in a very crude and early form, because you import all the data inside there, and all the syncing, animation, and maintenance and stuff is done in the tool. Again, the small turnaround times, the immediate feedback was essential for getting the right result. These totally, completely different guys who did this came up with this tool. Any similarities? Purely coincident. Which is basically a timeline spline editor. But we took two important aspects from this tool. First, the tool-based approach works for demos, very good. And the second one was the way the textures were painted. Because Fiverr knew how these textures were painted, and he came to me and told me that if I would implement a very small set of basic functions, he could do the same textures in 64K, or textures with a similar quality. And that was the seed we needed to start the FR08 project. Building a texture generator, which had the same functions that were used to paint the textures used for Kasparov, painting the same way an ordinary graphician would be painting using Photoshop, just that we don't save the bitmap, we save the commands. And of course we extended the concept to textures, meshes, scene, graph, everything you need to do a demo. The sound is an exception, because the sound was done by KB in a separate project, writing that synthesizer for FR08, which were later then combined. So the sound is not done with our tool, it's done with another tool. But everything which related to FR08 was done in one tool. There's one problem. To get an intro of the size of FR08, we need thousands of operators. One operator there are three kinds of operators. Operators which generate something, may it be textures or meshes, doesn't matter. Operators that modify something, like transformations, color changes, and operators that add two things together. Well, it's a huge amount of operators we need to get the demo done. The first attempt I tried was making a scripting language, and it was a total failure, because it was so complicated I couldn't even use it myself, although I wrote it. The second idea was to make some kind like bus with arrows pointing and boxes connected by arrows. But I didn't even try that, because I assumed that the amount of arrows needed to do this demo would be so huge that there's no chance of ever finishing it. So I came up with the idea of operator stacking. What would happen if I leave away the arrows? And this is this interface. You see, just imagine these boxes were connected with arrows, and so then you get something like bus. But these boxes are not connected by arrows. They're just stacked off on each other, because the connection is obvious. It's from the top to the down. As long as you're building trees, this works perfectly. I'm going to show how this looks if you work with it. This is the generator we used for FR08. And this is, whoops, no, abbrechen. Okay. This is a simple texture. I think it wasn't used in FR08. There's a lot of stuff in there, but it's a good example how one could build a texture. This is some kind of shiny floor with something like this, with tiles. This is done by adding primitives together. It starts with a rectangular, then we zoom it a little bit, we get this. A little bit of blur. Blur is one of the most important operators. You can do almost everything by just blurring it. Then For instance, if you have some random dots and blur them, you get something which is a little bit... We didn't have Perl and noise back then. We did everything by just taking dots and blurring it. Actually, it gives you more control than Perl and noise, but it has other disadvantages, so that I prefer Perl and noise now. Now we made this a little bit noisy because we subtracted these dots from this, and now we store it. This is a beautiful tree of operators. We need this store texture twice to make the final texture. This is here store, and here's a load, which just loads it in. The first time we need it, it's used as a bump map, so that it looks like this. Now it's the shiny stuff. We only have to get rid of these borders. This is done by taking this texture, doing some kind of color correction to it, and subtracting it, and we have the final texture. Built out of simple stuff. Now we can store it and use in the demo. But we can go even further. We can use it as it is in the demo, or we can load it again and do some more tricks to it. For instance, one could say we want to have it in different colors. So that I first make the lower half darker by applying this. And then we make this a little bit lighter. And voila, we got a different texture which is practically for free because we only did a few operations. We could also take this texture again and do some more stuff. It's like add a light glow to it or stuff. And so we can build huge amounts of operators and plug them together for a demo. It's the same for how it is called, meshes. Where was that mesh? Schmock. Yeah. Yes, you might remember from the demo this horn, which was just a cylinder. Actually, the cylinder is a little bit more complicated. What was the key? I don't know anyway. And then it is multiplied, put many times there with scale translate applied to it. We do the same on the other side, and one in the middle, and we have this horn. So we can just plug together large objects. The whole demo is then in this, and there are a huge amount of operators involved. And one of the major aspects of the tool is that you don't lose your overview about all these operators. And this operator stacking proved to work quite well for keeping track of all the stuff. So this is how we did FRO 8. And we expected this to be adopted very fast by the demo scene because we were quite sure that this is a superior way of doing intros. But strangely, the first guy who ever was able to imitate it was somebody from our own group. It was Rück. He started a project of doing a texture generator for a 4K intro, which was never written. And this turned out the graphicians wanted more features, and maybe we could add a little mesh editor to it, and maybe we could add this or that, and it turned out to be a complete tool, just like the FRA tool. It has a slightly different approach because while the FRA tool, we try to give all the possibilities to the graphicians that are in there. The FRO 13 tool tried to make everything as simple as possible, which turned out that more people were able to use it. And all the other intros were done with this tool. As you can see from the screenshot, it's also a lot more beautiful than whatever I did. There's a lot of work making this tool look finished. But it didn't matter a lot. I continued with my own tool. For FRO 19, I had to rewrite it completely from scratch because I have learned so much writing the first tool that I had to redesign. And the operator concept worked so well that I chose that everything is an operator. Not only textures, meshes, scene graphs, materials, timelining, syncing, every kind of animation is done through operators here. There's some flaws in the concept, that's why I have to rewrite everything again. But it worked very well, and it's used for the FRO 19, FRO 25, and actually FRO 31, which is going to release at this party. here we see a screenshot. You see all these tools look the same. We have the same kinds of windows. We have a 3D window here. We have a list of pages. We have the operator page here. Here we have values we can change and drag around. But the difference is what's working behind there. So here we have the Werkkzeug, which was used for FAO 19. Oh, I have to press here, okay. Yeah. Here we see how everything is an operator. This is the first scene in the whole thing. And we have here texture operators creating textures. This key. We have mesh generators creating all the geometry, scene graph operators who build together the scene, a camera operator who has the camera control. This is a time operator which actually places the whole thing in the timeline. And there is also a demo operator, you see that the time operator is also store, and here all the parts get loaded together. And here's the metronome with the sound operator who adds the sound to the demo. Of course, nobody wants to do the timelining by changing numbers somewhere hidden in time operators. There's a separate view which shows the timeline where you can which key? This key. Where you can actually see the whole timing and change it. And when I press such an operator and I change something here, you see how the operator automatically is changed too. I could also do this here. It's just the same. And how could one do animation? One important idea was, for saving memory of course, that most animations don't need a spline. Most animations are simple fades, linear ramps, fading in and fading out, maybe some sine functions. So we came up with a system where I have to search for the right page. Spike Jones, yeah. We came up with a system where I can do the timing just with operators. You see these pulsating movements are not done by making a spline which is going in many spikes. It was done by saying these spikes are all ramp downs, and these ramp downs give a certain pattern, like the speed pattern. A 0 is nothing happens, a 3 is a strong movement, and a 1 is a small movement. And you can follow how there was a strong, too small, and how these numbers make up the beat of the movement. This is much easier to edit than having to drag around the splines. So actually that was the concept of the FAO 25 tool, that everything is done with operators, with a few helps, but the great thing about it is that you can move around the operators so easily by just dragging them, and we have nothing hidden. We continued our work with demos. The FAO 25 just used a slightly improved version of the Werkkzeug. We also added support for importing character animations, which were done with XSI, Softimage XSI. But what made this demo so popular was, among other things, this glowing stuff we did. And now I want to be a little bit technical, coders only talk, how this glow was implemented, because I found that many people asked this question and haven't found out. To do image post-processing, there are a few very simple operations and some a little bit more complicated operations. One of the you need to implement to get full control about your image post-processing. One very useful is just change the brightness. Take an image, multiply it with a constant, for instance by drawing a large triangle, and then you may make things brighter or less bright. Of course, you need adding 2 images, which is trivial, or finding the highlights of a scene. This is also trivial. You only have to subtract a constant color, and everything what remains on your screen is the bright things. you may need to add a little bit of brightness after that, because these bright things are then, of course, if you add half of your luminance, then you only got some not very bright highlights, but you only got the highlights. If you multiply this again, then you get strong highlights. Another very simple effect is the feedback, where you take the last frame and add it to the current one, a very cheap way of blurring everything, which I actually don't like, because I don't like being dependent on the last frame. But it's so cheap that it's absolutely worth mentioning. So the last two, the Crashzoom, the blur, require a little bit of tricky programming if you don't want them to run very slow. We start with the Crashzoom. The Crashzoom, or radial blur, is the effect that you get when you take an image and paint it, let's say, 16 times over each other by slightly zooming it. Then you get these effects that rays are coming out of the image. But using 16 or 64 layer, which you need to do it with a decent quality, would eat up quite a lot of frame rate, of fill rate. It will be too slow, or at least it is too slow for me. So there's an approach that can reduce your amount of hardware a lot. You take your image, render it to a texture twice with zoom factors 1 and 2. Now you get two versions of that image, one large one and small one. Now you take that, use it as a texture, and repeat with zoom factors 1 and 1.5. Now you got 4 versions. Zoomed by 1, zoomed by 1.5, zoomed by 2, and zoomed by 3. If you do it again, you have 8 versions. With 4 steps, you got 16 layers of transparency. With 6 steps, you get 64. So with very few steps, you get an absolutely smooth radial blur without eating up all the bandwidth. And that's only the unoptimized case. You can do a lot of tricks to make it even faster. But that's the basic idea. I think this was first used in Kasparov, and it was also used in FR8. So it's actually a pretty old trick. The other thing you need to do all this glare stuff is the blur. This involves some more tricks. The first trick is that, of course, if you want to make a blur about a large area, you can first blur it in the X direction and then in the Y direction, so that you don't have a 2-dimensional blur, but 2 1-dimensional blurs, which are a lot easier to implement. If you want to blur 16 pixels in a row, you have to read 16 pixels and add them. But you can use the texture filter to read 2 pixels at a time, so that you actually, with a 2 texture hardware, like a TNT2 or a GeForce 1 or 2, you can read 4 pixels in 1 pass, so that you could actually do the a 9-pixel blur in 2 passes using additive blending. To make even larger blurs, you first blur by 9 pixels, and then you go in larger steps. This adds a few artifacts, but you can ignore these artifacts. If you are a little bit aggressive and mean on how you are sampling these larger steps, you can get quite a good blur with very few loss of frame rate. And if you have all this addition and subtraction, we can combine it for the glare effect. First you find the highlights, then you blur the highlights, and at last you add the original image to the blurred image, and then you have only the highlights being blurred over the whole screen. And this is basically what's done in FR25 all the time. Of course, all this blurring you can do in a lower resolution to save even more bandwidth, because you still have the original image. If you add the blurry glares in a low resolution to the original high resolution image, nobody will notice that you've done something evil to your graphics. So this is maybe I should have made a whole talk about this topic, but this is a fast way through how we did these effects. And of course, we don't need pixel shaders for this. You can do this on a TNT2 hardware, as it was already done in Kasparov, or you can do this on a GeForce 2 or whatever you might, or GeForce 4MX. It will run everywhere. You don't need any fancy hardware for that to get that implemented. We care a lot that many people can watch our demos, and requiring pixel or vertex shader or requiring a graphics card from a certain vendor dramatically decreases the number of people who can watch our stuff. And that's why we try not to do that. I like audiences. And I don't want to limit my audience because I use some stupid extensions or hacks that don't work everywhere. But, well, with this assembly and especially with Christmas, pixel shaders will become so common that we can use them without being too concerned about compatibility. How did we continue? Yeah, we made yet another tool. We had a complete rewrite for FO30. There were so many new ideas that we saw no way of implementing it into our old tool. It is at the moment in a totally catastrophic state, but we are working on it. And again, these tools look all the same. You have the windows with the list where you can select. You've got the view. Actually, we have 2 viewports here. You can change parameters, and the most important window where we rearrange our operators. This is just for debugging how many processing time is landing in which part of the engine. Yes, I want to go back to the turnaround times because this is the most important topic for getting more creativity, more productivity to your graphicians. Here we have the Generation 3 tool, which will be renamed soon. This is something I plugged together. This is a 3D scene with some. Now I can rotate it. And I want to add the glare effect. And the cool thing about this operator stacking system is that if I want to add the glare effect, I just take one. I know that this screen already has one. Copy, paste, and now I have to make some space so that it can fit there. And now we have the glare effect. You see here we have knobs. Actually, we would need a graph for doing this, but we only have a tree. That's why we have knobs here. We have here the color operator who does the subtraction. We have the original scene. We subtract this constant color so that we get the highlights. We do a small blur. We do a large blur. Merge it together, and now we got these glares. Here's another scene, which is just some stupid background. We merge it together, and now we got the scene. And you see, by adding the glare, I totally spoiled the colors. It's much too bright. I hate it if things go white. They may slightly go to white, but they may never reach white because that looks ugly. So I have to adjust the colors. But where? I could adjust the color in the texture. I could adjust the color in the material. I could adjust the color in the FX chain, and I can change I can change the size of these things. So if I would be a graphician, I would spend a lot of time tweaking these values, and because I have access to all values at the same time, I can easily make the scene better by just changing the stuff as it. Well, maybe I want a little bit more highlights, so I subtract less. And I want this bigger. I don't want it to go white. And now this is too bright. I have to make this even less bright so that it looks good. And now I think this is okay. There's too much white here. I would actually usually make it less white. Usually I wouldn't do this anyway because we have graphicians to do this. I only write the rules. And they are much better at picking colors than I am, which is obvious, this example. But I think you got the idea. First, how nice it is to rearrange things in this tool because everything is an operator and you just copy, paste, move it around. And the other thing is, because I have total control about all aspects of the demo, and I can change everything, I can work very fast with it. I can change the texture, and I see how the change of the texture changes the image after the glares are applied. And this is a really bonus. Yeah, turnaround times. GUI design. My opinions about GUI design are a little bit strange. The first thing is I hate overlapping windows. They are always in your way. I've seen tools where the user spends 10% of its time rearranging windows because they don't fit where they belong. The splitter windows we used here, or most other modern game tool designs have, are a much better way to change this problem. You will never have the problem that windows overlap too much. I also don't like icons, because if you are familiar with the program, you are not clicking buttons, you are pressing the key shortcut. If you're unfamiliar with the program, you see an interface with thousands of buttons with nice arrows rotating some stuff, and you have no idea what these buttons are before you press them. Maybe except if you very often used icons, which you know from other programs. Usually icons are pretty meaningless to the beginner, and they are pretty useless to the expert anyway. Therefore, I prefer buttons with a name on it. This is the most people don't believe it. Don't use Windows, use your own GUI library. I've seen several GUI libraries, and unless you're working in a large team of programmers where you have to work within the standards, if you're writing a small tool, then you have no problem with your GUI library anyway. Just code it yourself, and you are easily done. Because the time learning any other GUI library is usually the time you would need to write it yourself. If you're doing a really complicated tool, then the GUI library you are using will fuck up anyway. This always happens. You will spend a lot of time overloading predefined classes with new functionality that you could write yourself much easier if you don't have to work in that framework. You have to find bugs. So if your project is so large that it requires a really complicated GUI library, then better write it yourself. This is the same Microsoft does. Microsoft is not using the same GUI library. They write a new GUI library for every major release of the Office pack. Actually, they wrote a new GUI library for their Visual Studio, because it's much too complicated writing a GUI library that fits everybody's need. If you write your own code that can only solve your own problems, you're maybe better off. And the other thing is, don't hide complexity from the user. If the thing you want to edit is complex by itself, and you think you maybe hide that complexity from the user, then the user will run into traps. Because without knowing what's going on behind the doors, then he won't be able to use the tool right. It's best to remove the complexity if possible, and if it's not possible to remove it, make it somehow explained to the user, but do not hide it, because this makes bugs. This makes traps for the user. It just makes your program behave in an unexpected way, and usually this is not a good thing. The most important thing when you write a user interface is there are functions which need to be activated. There's buttons which must be pressed. I think every function should be accessible by the mouse, with a name printed on it. No funny icon, a name. You press a button and you know what will happen because you have read what's on it. Of course, every important function must have a keyboard shortcut. And if you print the name of the keyboard shortcut besides the button, then the user will press that button 5 times, and the 6th time he will use the shortcut because that's faster. So you train your user for using the shortcuts to become more productive. And to make him even more productive, you should put the most important shortcuts on the left side of the keyboard, because the right hand of the graphician is on the mouse. You will see that if you put the shortcuts on the right side of the keyboard, many graphicians choose not the shortcut but use the mouse to click on the button. And this invalidates the shortcut. Don't be tempted to put the shortcuts on letters that have a meaning. It is much more important that the buttons are at the right position, so that they can be easily reached. So if somebody of you tries to do a really big editing project, this isn't as difficult as you might think. You need a good base library and a good GUI, user interface library. This is the first problem, and well, you must get somehow through there. But if you have your base stable and running, then such a tool is an editor for a data structure. So the next important step is that you must be sure what is the data structure you are editing. I do this by writing a header file, a well-commented header file that explains every aspect of the data structure. This is the most important aspect of the whole design. Once you have the data structure, you can write a simple program that fills the data structure with dummy data, just to have something to play. Because the most difficult part when writing an editor is adding new data to it. Modifying data is easy to write. The code to display the data on the screen is easy to write, but the code to add new data is a little bit more difficult. So if we start with a fully featured data structure, which was generated by a few lines of code, who just built up some dummy data, then we can write some windows that display the data, which is quite easy if you have a user interface library that works. Then you can add the code to edit the data, as well as just moving things around, as well as adding new items. Then loading and saving, this is a big problem. You can make many errors while loading and saving. And at this moment, your tool is complete. You can give it to your graphician. He can work with it, give you feedback, and he will come with feedback. You want 1,000 little features to make the tool usable. And this will eat up all your spare time writing these features, not writing the 3D engine or the demos effects. You will write features. But this is important. So this is actually how I do my tools in exactly that order. And I spend very few time setting the tool up. Most of my time goes into adding little features. And, well, that was it. I was very fast here, much faster than I expected. But you may ask questions now. Yes. The farbrausch demos we do, actually the Werkkzeug has two programs, the editor and the player. Everything is done with the editor, although we import, in the case of a demo, we import JPEGs and we import models. In case of Candytron FR30, the character animation and the modeling of the girl was done out in Softimage XSI, crunched into an insane level, and then imported into the tool. But everything else is done in the tool. Then we export the data blob and include it into the player executable. And then we got a final running executable, which is a demo.
I have two questions. First, you said that recommend to use your own UI.
Yes.
I agree with you. What do you use for rendering?
In the past, we agreed on using our own user interface library, but the rendering could as well be done with DirectX or OpenGL, completing the 3D engine, or you could mix the standard Windows user interface drawing primitives for text and the GDI, as it's called. It doesn't matter. Both has its advantages and disadvantages. If you use DirectX or OpenGL for your editor GUI, everything will be smooth in one screen. You can do a lot more tricks with that. But unfortunately, modern graphic cards have a delay. Every time you move the mouse, you have to go through the driver, who does some buffering, and then you have the double buffering. So that if your code is perfect, you have at least 2 frames delay from every user input to what's happening on the screen. If this frame rate drops rapidly, then this may be a problem. So I prefer doing everything in DirectX, including all GUI stuff, user interface stuff, but this has a disadvantage of the delay you can't get around.
The editor was running on DirectX.
The generator for FR8 was running on GDI, but all future tools, the Werkkzeug for FR19 and the Gen 3 are running on DirectX completely. Actually, you can run them in full screen if you want. That's no problem.
And then my second question is, why did you choose Softimage?
We chose Softimage XSI because we think it's the best 3D package around, but this is a personal opinion of the people using it. I'm not going to do any marketing fights here, but we tried them all, and the shows, for us, it was obvious. Maybe one of the reasons is that we started the whole stuff with Softimage 3D in Killer Loop, and at that point of time, that was the only software available that could do decent UV mapping. If you have ever seen the Softimage 3D UV mapper and compare it to everything available from other vendors at that point of time, then you might understand why we only want to use that and nothing else. And they improved on there. But this is, I'm sure most of you disagree with this and have their perfect reasons for doing that. Any other questions? No more questions? Here's one.
Have you ever had an effect that you wanted to do, but you cannot put it in the editor?
No. Since I coded the editor myself, I can put everything in there. If I can make it in the sandbox, I can also do it in the system, which is quite obvious. It's all DirectX, and if I have a real problem, then I write a hack for it. And there are always ways going around things. Yeah. I have what? Recursion as an operator. Actually, that was a very important idea I wasn't able to get running. Recursions require subroutines, and subroutines are something which doesn't fit well into the operator stacking model. There are other ways of doing it. I've actually one of the reasons I rewrote the tool was that I wanted to add recursion to it, but I failed. But I found out that I had a vision of how our graphicians should be doing graphics, and this involved recursion. But they have found out that it's much too complicated, that it's much better to do it the traditional way, without recursion. I think we are missing some potential by not supporting it in our Werkkzeug, but our graphicians never demanded it, and I wasn't able to get it running, not in this concept. Something more? I was so fast, there must be questions. But if there aren't, then that was it. Okay.